A pivot point is any object that can affect a log's balance when cut. As a log is cut and the load shifts, a pivot point could cause one end of the log to swing downhill and the other end of the log to pivot uphill towards the faller. To avoid having the log pivot, the faller makes his cuts so the log will roll free of the stump. In this situation, the faller chooses a bucking length as close to the stump as possible to maximize log length while maintaining a safe position. Brush out any debris that could fall or fly back at you when the log drops, and clear an escape route. Before you start to buck any tree, you need to assess the area for hazards. The faller must assess each tree so he knows what will happen when he makes his cut. In this blowdown situation, the faller identifies a danger tree which could fall on him while he's bucking the log. The faller must remove the tree before he begins bucking. In this situation, the lay of the tree makes it difficult to determine the bind. Also, the fact that this tree is lying on top of another tree adds to the danger. The faller chooses the safest bucking position available to him. He avoids standing in the V of the two trees, which would limit his ability to escape. He also avoids standing on the lower tree, which could shift or roll when the cut drops. As you measure the tree, determine the safest place to stand to make the cut. You must always cut from the high side of the tree. Check the tree for stability and determine what it's likely to do when cut. Because this tree has a small amount of top bind, 2 simple cuts are all that is needed. Top cut, 1/4 the diameter of the tree. Start your bottom cut, making sure it lines up with the top cut. Move out of the way as the log drops. On smaller trees, it's acceptable practice to tape and limb the tree at the same time. As you measure the tree, determine the safest place to stand to make the cut. You must always cut from the high side of the tree. Brush out a working area and escape route, and remove all debris. Check the tree for stability and determine what it's likely to do when cut. Because this tree has a small amount of bottom bind, 2 simple cuts are all that is needed. Underbuck, 1/4 the diameter of the tree. Line up the bottom cut and make a second cut, starting at the top. Move out of the way as the log drops. Bind is involved in virtually every bucking situation because stumps, windfalls, and other objects prevent trees from lying flat. The hazards for the faller are that the bar will become pinched or they will be struck by the falling log. Bind creates 2 different pressure points, resulting in the wood on one side of the tree being compressed, while the wood on the other side is under tension. This tree has a top bind because it's being supported at both ends. The force of the bind is pushing down. Start your cut on the far side, making sure you cut the bottom corner. Then, come back and make your top cut. Make your final cut, reaching under and up, cutting the wood furthest from you. The faller makes his last cut up from the bottom to relieve the tension and allow the log to fall away. The faller assesses the tree. He identifies that it's well supported, but has a potentially dangerous pivot point. If this pivot point is not removed before the tree is cut, the butt end will drop away and the cut end will swing up, potentially striking the faller. The faller removes any branches that could cause a kickback. The faller kneels down on top of the tree and makes the first of 2 cuts. The purpose of these 2 angled cuts is to reach the outside lower corner. Finish the side cut by cutting into the center of the tree. Scribe down 3/4 of the diameter of the tree and bore in. Continue to bore into the center of the tree and then cut all the way through to the bottom. Now, saw down from the top of the tree and cut the holding wood. Reach as far around the tree as possible and cut the bottom corner. Once these cuts are complete, the faller can never return to the lower side of the tree. The faller bores into the center of the tree and then cuts all the way through to the bottom. The faller cuts down through the holding wood. Move out of the way as the log drops. In this scenario, the tree is supported at both ends, creating a heavy top bind at the bucking length. This puts the tree under extreme compression. When bucking, the holding wood can break with sudden force, putting the faller at risk. To control this reaction, the faller makes a V-notch at the top of the tree. This relieves the compression, allowing the log to drop in a controlled manner.